Hello and welcome to this presentation from Pluralsight. My name is Andrew Mallet and I'm here as your instructor to help guide you through the module Managing Shared Libraries. And we're going to be looking at managing shared libraries. That's the objective that we're looking at. To get there, we'll be running through some demonstrations. And these demonstrations are going to include how we can view shared libraries for given programs. We'll look at the locations, so the directories where we're going to find our shared libraries. And we'll be seeing how we can view the contents of our shared library cache. So to begin with, let's look at how we can view shared libraries. Well, here you go. You can see that we've logged on as Tux, a standard user on our CentOS 7.2 host. I'm in the user's home directory, but it doesn't really matter where we are. If I want to go through and look at the shared libraries for a particular program, I can then go through and say USR and then bin and let's say ls. We can see then for the ls program we've got a few shared libraries. Now the idea of shared libraries is rather than every command that needs access to similar resources on the machine, rather than every command having to include that code, we can reference a shared library. So we have a library of code that can be shared by multiple programs. When we're looking at it, let's say some of the things that we can see here, the libpcre, so POSIX, compliance, regular expressions. Now we'll see that there'll be a number of utilities that's able to use those regular expressions. Let's go through and take a look at, let's say, the program grep. We can see here that grep also makes reference to that same library module, pcre. So we can see that we're able to use then regular expressions with either grep or the ls command, and we won't have to worry about any incompatibilities. They are going to be the same because it's referencing the same library module. It's also going to make our code base much smaller because we don't need to include within each application the code. We have it then compiled into this shared library. The shared libraries have the .so extension, as we can see. That's really just S for standard and O, well, would you believe, for modules. If I clear out of the screen here, we can also go through and see a little bit of the shared libraries. If I go through and look at the pmap command again, so if I look at the process map, I'm going to do it for the bash shell. So I'm just going to look at the process ID of my current shell. Now we get to see then the library modules that are loaded within the shell. We could also see this if I went through and used the LDD command and then usr/bin/bash. So we can see the library modules that are referenced, and these library modules will also then be able to see that are loaded when the bash shell is running. So from a user perspective, we can find out which modules are required by an application. Generally, we're not going to look at it, but we might look at this if we've got some problems that we want to try and resolve. Perhaps a module has become corrupt or whatever. But there you go, we've been able to view and list our standard modules using the LDD command, but we also saw we could use it with the process map command. But don't forget, when using LDD, we have to put the full path to the application. I can't just go through and go LDD space bash, unless of course bash is in the current directory. Now, having looked at how we can view our shared libraries, we're going to start looking at some of the locations that we're going to find our shared libraries in and how we can configure those locations.